Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Benjamin Peirce, a name synonymous with mathematical brilliance in 19th century America, forged a unique path through the intellectual landscape of his era. His legacy, a tapestry woven with threads of innovation and profound insight, continues to resonate within the halls of mathematics and its applications. This exploration seeks to illuminate the core of Peirce's contributions, focusing entirely on the mathematical realms he so masterfully navigated. We will journey through his groundbreaking work, examining the challenges he confronted, the novel solutions he devised, and the enduring impact of his ideas. The mid-19th century presented a fertile ground for mathematical exploration, yet it was also a time of significant limitations. Established frameworks, while providing a foundation, often proved inadequate to address the burgeoning complexities of algebra, geometry, and the emerging field of applied mathematics. Existing methods, while useful, often struggled to cope with the intricacies of higher-order equations, the subtleties of non-Euclidean geometries, and the demands of a world increasingly reliant on quantitative analysis. Peirce, with his unparalleled intellectual agility, possessed the capacity to perceive these shortcomings and to formulate solutions that transcended the boundaries of his time. Early in his career, Peirce encountered a problem that would define his approach to mathematics: the challenge of understanding and classifying algebraic systems. The established methods, rooted in the work of mathematicians like Euler and Lagrange, were proving cumbersome when dealing with systems beyond the familiar real and complex numbers. The existing tools struggled to provide a clear, unifying framework for understanding the properties of these more abstract structures. Consider the problem of solving equations. While solutions existed for linear and quadratic equations, the methods for cubic and quartic equations, developed during the Renaissance, were exceedingly complex. The general quintic equation remained a formidable challenge, with no known algebraic solution in terms of radicals. Furthermore, the concept of algebraic structure, a fundamental notion in modern mathematics, was still in its infancy. Mathematicians pondered the definition of an algebraic system and methods for classifying and comparing different systems. Peirce's response to these challenges demonstrated his exceptional intellect. He aimed to surpass limitations of existing methods. He possessed a remarkable ability to discern underlying patterns and develop novel approaches that yielded significant insights. This was evident in his work on linear associative algebras, a field where he revolutionized the understanding of algebraic structures. His unique approach began with a clear recognition of the need for a more systematic and general framework. He sought to classify all possible algebraic systems based on their fundamental properties. This involved defining what constituted an algebra, identifying the key operations, and systematically exploring the various structures that could arise. He recognized that the properties of an algebra, such as associativity, commutativity, and the existence of an identity element, were crucial in determining its behavior. To accomplish this, Peirce developed a powerful new method. He focused on the concept of idempotents and nilpotents, special elements within an algebra that played a crucial role in its structure. An idempotent element, when multiplied by itself, yields itself. A nilpotent element, when raised to a certain power, equals zero. By analyzing the relationships between these elements, Peirce could categorize different types of algebras and determine their properties. This method enabled him to classify all algebras of dimension 3 and 4 over the real numbers. This was a monumental achievement, providing a comprehensive understanding of these systems. The work offered a general theory, a framework that could be extended to higher dimensions and to more complex algebraic structures, rather than just a catalog of specific examples. The significance of Peirce's work extended far beyond the immediate results. He established the foundation for the modern theory of algebras, influencing the development of abstract algebra as a whole. His classification of algebras provided a template for other mathematicians to follow. It demonstrated how to approach the study of complex algebraic structures in a systematic way. His work also had practical implications, influencing the development of areas such as quantum mechanics and electrical engineering, where algebraic structures play a crucial role. Peirce's approach was characterized by deep understanding of the underlying principles of mathematics, a willingness to challenge established norms, and an extraordinary ability to synthesize diverse ideas into a coherent whole. His approach was also marked by profound appreciation for the beauty and elegance of mathematical structures. He viewed mathematics as a language for understanding the fundamental nature of reality, a language that revealed the hidden order and harmony of the universe. His intellectual curiosity, his commitment to rigorous analysis, and his ability to see connections where others saw only complexity established him as a leading figure in the mathematical world. His contributions, initially published in the Journal of Mathematics were quickly recognized and celebrated by his peers. They exemplified a new standard of mathematical rigor and insight. Peirce's influence was not limited to his direct contributions. He was also a dedicated educator and mentor, inspiring the next generation of mathematicians. He served as a professor at Harvard University for many years, nurturing the talents of his students and fostering a vibrant mathematical community. His legacy endures through the significant contributions of his students to the field. Peirce's work marks a pivotal moment in the history of mathematics. His innovative approaches, powerful methods, and profound insights transformed the landscape of algebra and laid the groundwork for subsequent developments. His legacy is a testament to the power of human intellect, the beauty of mathematical thought, and the enduring importance of pursuing knowledge. The subsequent exploration will detail his contributions to algebra, further illustrating the depth and breadth of his mathematical genius. Peirce's mathematical prowess extended into the intricate world of algebra and the theory of equations, leaving an indelible mark. In the 19th century presented formidable challenges in solving higher-order polynomial equations and refining algebraic methodologies. Mathematicians grappled with complex equations that resisted straightforward solutions. Seeking more effective techniques, Peirce met this challenge with innovative approaches that expanded algebraic understanding. His contributions to algebra are characterized by profound understanding of its underlying structures and a remarkable ability to manipulate algebraic expressions with ingenuity. He possessed an knack for identifying hidden relationships and symmetries within equations, enabling elegant and efficient solutions. Peirce's work sought a more systematic and rigorous approach to algebra, moving beyond ad hoc methods. One of Peirce's significant contributions lies in his exploration of algebraic forms and their properties. He investigated the structure of polynomials, examining their roots, coefficients, and relationships. His work in this area built upon the foundation laid by earlier mathematicians such as Maurice Galois and Joseph Louis Lagrange, who had made groundbreaking discoveries in the theory of equations. Peirce brought a unique perspective and insights to the subject, expanding boundaries of what was known and understood. He developed novel techniques for manipulating algebraic expressions, often employing clever substitutions and transformations to simplify complex equations. These methods enabled him to reduce higher-order equations to more manageable forms, making them solvable. Peirce's mastery of algebraic manipulation was truly exceptional, and his ability to navigate the intricacies of complex equations demonstrated his mathematical skill. Peirce's original theorems stand as testaments to his deep understanding of algebra. He formulated and proved several important results that advanced the field. While some of these theorems may be less well known today, their significance in the context of 19th century mathematics should not be overlooked. They provided new tools and insights for solving algebraic problems and deepen the understanding of algebraic structures. To illustrate Peirce's approach, consider the challenge of solving a quintic equation, a polynomial equation of degree 5. Such equations had long challenged mathematicians, as there is no general algebraic formula analogous to the quadratic formula for finding their roots. Peirce, while not discovering a general solution as it had been proven impossible, explored specialized techniques and conditions under which quintic equations could be solved. His work involved intricate manipulations of the coefficients and the application of advanced algebraic concepts. Peirce's focus extended to the broader theory of equations, which deals with the properties of polynomial equations and their solutions. He investigated the relationships between the roots of an equation and its coefficients, exploring symmetries and patterns that govern these relationships. This line of inquiry led him to develop new methods for analyzing and solving equations, providing a deeper understanding of their structure and behavior. His insights into the theory of equations also had implications for the study of algebraic functions. Algebraic functions are functions that can be defined as solutions to polynomial equations. Peirce's work on equations provided a framework for understanding the properties and behavior of these functions, contributing to the development of algebraic function theory. The significance of Peirce's contributions to algebra can be appreciated by considering their impact on subsequent mathematical developments. His work helped to pave the way for the modern abstract algebra that emerged in the 20th century. Abstract algebra focuses on the study of algebraic structures such as groups, rings, and fields, which are defined by their abstract properties rather than by specific examples. Peirce's emphasis on the underlying structures of algebra and his exploration of algebraic forms resonated with the spirit of abstract algebra, influencing its development. While Peirce's specific theorems may not be universally taught in contemporary mathematics courses, their historical significance remains substantial. They represent a crucial step in the evolution of algebraic thought, bridging the gap between classical algebra and modern abstract algebra. His methods and techniques, though sometimes specialized, demonstrate a deep understanding of algebraic principles principles and a remarkable ability to apply them to challenging problems. Moreover, Peirce's work on the theory of equations continues to have relevance in various areas of mathematics and its applications. The study of polynomial equations and their solutions remains a central topic in algebra, with applications in fields such as cryptography, coding theory, and computer science. Peirce's insights into the structure and behavior of equations provide a valuable foundation for understanding these applications. Peirce's influence extends to the teaching of algebra as well. His emphasis on conceptual understanding and his rigorous approach to problem solving serve as a model for instructors and students by focusing on the underlying principles of algebra and encouraging students to think critically about algebraic concepts. Peirce's legacy continues to shape the way algebra is taught and learned. His contributions to algebra and the theory of equations demonstrate his exceptional mathematical talent and his dedication to advancing the field. He tackled challenging problems, developed innovative solutions, and formulated original theorems that expanded the boundaries of algebraic knowledge. His work serves as a testament to the power of algebraic thinking and its enduring importance in mathematics. Peirce's impact is reflected in the way he approached mathematical problems. He emphasized the importance of rigorous reasoning, clear definitions, and careful attention to detail. These principles are essential for success in any area of mathematics, and Peirce's example serves as an inspiration to mathematicians of all levels. His legacy in algebra is one of innovation, rigor, and a deep appreciation of the beauty and power of mathematical thought. He pushed the boundaries of algebraic knowledge, providing new tools and insights for solving problems and deepening the understanding of algebraic structures. His work continues to resonate with mathematicians today, reminding them of the enduring importance of pursuing mathematical truth with creativity and dedication. The next section will explore Peirce's significant contributions to the field of geometry. Peirce's contributions extend into the intricate tapestry of geometric exploration. His approach, marked by rigorous precision and a profound understanding of the fundamental principles governing spatial relationships, left an indelible mark on the development of geometry. This section will delve into the specific geometric contributions of Benjamin Peirce, highlighting the problems he addressed, his innovative solutions, and the enduring legacy of his work. Peirce's geometric investigations were deeply grounded in the challenges of his era. Existing geometric frameworks, though fundamental, often lack the precision and rigor required to address complex spatial issues. The limitations of Euclidean geometry, while powerful in its simplicity, were proving inadequate for certain advanced applications. Peirce acknowledged these limitations and undertook a quest to broaden the scope of geometric understanding. His approach to geometry differed from prevailing methodologies. Instead of relying exclusively on established axioms and theorems, Peirce sought to develop novel geometric concepts and methods. He explored the very nature of space, questioning its inherent properties and examining the relationships between various geometric figures. He meticulously examined the properties of curves, surfaces, and solids, seeking to uncover hidden relationships and patterns. A key contribution of Peirce's work lay in his exploration of non-Euclidean geometries. He recognized the potential for alternative geometries that diverged from Euclid's axioms. This pursuit stemmed from a profound understanding of the limitations of Euclidean assumptions. His work established the foundation for the later development of non-Euclidean geometries, facilitating revolutionary advancements in fields such as physics and cosmology. His investigations encompass the study of projective geometry, a field concerned with the properties of figures under projections. Peirce's insightful analysis of projective transformations and their implications for geometric configurations enabled a broader understanding of spatial relationships. He identified crucial properties that remained unchanged under these transformations, offering a deeper appreciation of the fundamental structure of space. Peirce's work encompassed the development of geometric transformations. He carefully examined the effects of rotations, reflections, and other transformations on geometric figures. Through meticulous analysis and rigorous proofs, he established fundamental principles governing these transformations, forming the basis for the development of group theory and its significant applications in mathematics and beyond. His understanding of geometric constructions was equally profound. He developed novel methods and techniques for constructing geometric figures, often with remarkable efficiency and elegance. These constructions, incorporating both analytical and synthetic approaches, provided new tools for problem solving in geometry. They broadened the scope of geometric constructions, achieving greater precision and generality. His contributions are deeply intertwined with the practical applications of geometry. His insights into geometric principles were instrumental in various fields, from engineering to architecture. His work's practical implications were substantial, facilitating the development of more precise instruments and techniques for measuring and manipulating spatial relationships. The enduring impact of Peirce's work in geometry is undeniable. His exploration of non-Euclidean geometries, projective transformations, and geometric constructions laid the foundation for subsequent advancements in the field. His meticulous attention to detail and rigorous reasoning continue to shape the way mathematicians approach geometric problems. His insightful investigations into the nature of space and relationships between geometric figures remain relevant to contemporary geometric explorations. His methods, while rooted in the 19th century, continue to inspire and guide modern mathematicians. His innovative approaches to geometric problem solving continue to resonate in contemporary applications, influencing the development of new geometric tools and techniques. Peirce's legacy in geometry is profoundly rooted in the way he approached mathematical problems. His commitment to rigorous reasoning, clear definitions, and careful attention to detail remains a guiding principle for mathematicians today. His contributions, arising from the intellectual landscape of the 19th century, continue to inspire mathematicians of all levels in their explorations. The next section will explore Peirce's profound impact on the development of mathematical logic, encompassing his innovative approaches to the foundations of mathematical reasoning. This will highlight the problems he addressed, his unique solutions, and the lasting implications of his work. The historical context and enduring influence of his contributions will be thoroughly examined. Peirce's intellectual pursuits extended far beyond the realm of geometry, encompassing a profound investigation into the very foundations of mathematical reasoning. He recognized the critical need for a rigorous logical framework underpinning mathematical structures, a need that existing approaches had not fully satisfied. This section will delve into Peirce's seminal contributions to mathematical logic, illuminating the problems he confronted, his innovative solutions, and the enduring impact of his work. The 19th century witnessed a period of intense scrutiny regarding the logical underpinnings of mathematical systems. Existing methodologies often lacked the precision and clarity necessary to establish a universally accepted foundation. Ambiguities in definitions, inconsistencies in proofs, and a lack of a common symbolic language hindered the development of a truly rigorous and comprehensive system of mathematical logic. Peirce, with his keen intellect and unwavering commitment to clarity, recognized these shortcomings and embarked on a path to address them. Peirce's unique approach to mathematical logic centered on the development of a comprehensive system of symbolic logic. He recognized the power of symbolic representation in clarifying complex arguments and establishing precise relationships between logical concepts. His innovative system, while not immediately accepted by the mathematical community, established a foundation for future developments in mathematical logic. He meticulously defined fundamental logical connectives such as conjunction, disjunction, implication, and negation. These definitions, expressed in a precise symbolic language, provided a framework for constructing more complex logical arguments. Peirce's logical notation, though evolving, demonstrated a profound understanding of the importance of a common language for expressing and analyzing logical structures. A key aspect of Peirce's work was his exploration of the concept of truth and validity in mathematical arguments. He sought to formulate clear criteria for determining the truth of statements and the validity of inferences. His analysis encompassed more intricate logical structures beyond simple propositions. He addressed the challenges of quantifiers, conditional statements, and the interplay between different logical operators. These investigations, though complex, were instrumental in developing a more rigorous and precise framework for mathematical reasoning. Peirce's insights into the nature of inference were particularly groundbreaking. He meticulously examined the different forms of deductive and inductive reasoning, exploring the conditions under which valid inferences could be drawn. His analyses provided a deeper understanding of the relationship between premises and conclusions, paving the way for more sophisticated methods of proof. He meticulously examined the interplay between different logical operators, striving to establish clear rules for constructing valid arguments. His commitment to precision and clarity in logical reasoning was a defining characteristic of his work. Peirce's explorations of the relationship between mathematics and logic were remarkably insightful. He recognized the crucial role of logic in supporting mathematical reasoning, and he sought to establish a rigorous connection between the two disciplines. He believed that logic provided the fundamental tools for analyzing and validating mathematical structures. His work highlighted the importance of shared understanding of logical principles for the advancement of mathematical thought. The significance of Peirce's work extends far beyond the specific contributions of his time. His innovative approach to symbolic logic, his rigorous examination of logical concepts, and his exploration of the connections between mathematics and logic profoundly influenced subsequent generations of mathematicians and logicians. His meticulous attention to detail and his commitment to clarity laid the foundation for many of the modern approaches to mathematical logic. His work became a crucial cornerstone in the development of this field. While his ideas might have had limited immediate practical applications in the 19th century, their influence on the development of mathematical logic is undeniable. His work, in its meticulous detail and profound insights, laid the groundwork for subsequent developments in symbolic logic, including the work of Russell and Whitehead. Peirce's innovations in symbolic logic provided a crucial framework for future generations to build upon. His insights into the nature of logic and its application to mathematics resonate even today. Peirce's impact is substantial. His rigorous approach to logical analysis and his development of symbolic logic continue to be relevant in contemporary mathematical thought. His commitment to precision and clarity in mathematical reasoning remains a guiding principle for mathematicians today. His work continues to inspire researchers in mathematical logic and related fields, providing a valuable framework for analyzing and validating mathematical structures. His focus on the precise definition of logical terms and his development of symbolic languages remain influential in contemporary logic. His work, rooted in the 10th century, continues to be read and studied by modern logicians. In conclusion, Benjamin Peirce's exploration of mathematical logic stands as a testament to his profound intellect and unwavering commitment to clarity. His groundbreaking work laid the foundation for many modern approaches to mathematical logic. His contributions, stemming from the intellectual landscape of the 19th century, continue to resonate with mathematicians of all levels, serving as an inspiration for their explorations. Peirce's legacy in mathematical logic transcends the specific results he attained. It is deeply rooted in the systematic and rigorous approach he brought to the study of mathematical reasoning. Benjamin Peirce's intellectual journey, meticulously charted through his mathematical and logical endeavors, reveals a profound dedication to precision and rigor. His contributions have profoundly shaped the trajectory of mathematical thought. His work remains a cornerstone of modern mathematical logic, a testament to the enduring power of meticulous analysis. The intellectual challenges Peirce grappled with encompass the fundamental questions of logical structure, exploring the very essence of mathematical reasoning. His relentless pursuit of clarity and definitions and the development of symbolic languages ultimately addressed the practical need for precision in mathematical discourse. His dedication to these fundamental principles laid the groundwork for future generations of mathematicians. Peirce's work on the nature of mathematical truth, rooted in the 19th century, displays appreciated understanding of the importance of formal systems. His insights into the structure of mathematical arguments foreshadowed the development of formal logic, a field that would flourish in the 20th century. This anticipation of future developments highlights the remarkable depth and foresight of his intellectual pursuits. His examination of the very foundations of mathematical reasoning, his systematic approach to the construction of logical systems, and his dedication to precise definitions substantially contributed to a more rigorous and precise understanding of mathematical structures. The problems of this time, the need for robust and unambiguous framework for mathematical argumentation, were directly addressed and resolved through his meticulous and profound explorations. The lasting impact of Peirce's work extends far beyond the specific results he achieved. His legacy lies in the systematic and rigorous approach he brought to the study of mathematical reasoning. His methods, characterized by relentless pursuit of clarity and precision, continue to inspire mathematicians, influencing the way they approach problems and construct arguments. His approach, with its emphasis on formal systems and symbolic languages, profoundly shaped the intellectual landscape of mathematical logic. Peirce's exploration of mathematical logic, while seemingly abstract, possessed practical dimension. His work provided a framework for rigorously analyzing mathematical structures, a crucial element in the development of more sophisticated mathematical theories. The profound impact of this work is evident in the way modern mathematicians approach problems, their preference for precise definitions, and their reliance on formal systems. His contributions, though sometimes overlooked in their immediate context, have become cornerstones of modern mathematical logic. His work, with its focus on the precise definition of logical terms and the development of symbolic languages, remains influential in contemporary mathematical analysis. His influence on subsequent generations of mathematicians is undeniable, shaping the very language and methods employed in the study of mathematical reasoning. The enduring relevance of Peirce's work in modern mathematical thought is evident in the continued study and application of his methods. His emphasis on formal systems and symbolic languages resonates with contemporary mathematicians, who find in his approach a powerful tool for analyzing and validating mathematical structures. His insights into the structure of mathematical arguments are highly relevant to the rigorous analysis required in modern mathematics. The elegance and profound implications of Peirce's work are evident in his meticulous approach to defining logical terms. His development of symbolic languages, while seemingly technical, provided a powerful tool for analyzing and clarifying complex mathematical arguments. His meticulous attention to detail, a hallmark of his approach, continues to influence how mathematicians frame and solve problems. Peirce's influence extends beyond the realm of pure mathematics. His work on logic and symbolic reasoning has profound implications for other disciplines, such as computer science and artificial intelligence. The need for precise and unambiguous language in these fields is directly linked to the foundations laid by Peirce. His legacy resonates throughout the broader scientific and technological landscape. His contributions, rooted in the intellectual climate of the 19th century, hold a timeless quality. His meticulous attention to detail, his commitment to clarity, and his profound insights into the nature of mathematical reasoning continue to inspire and guide mathematicians today. His work stands as a testament to the enduring power of rigorous thought and the profound impact of individual contributions on the evolution of mathematical thought. The intellectual landscape of the 19th century, with its burgeoning mathematical discoveries, was fertile ground for Peirce's unique contributions. His work, while sometimes not immediately recognized for its full potential, laid the foundation for many of the modern approaches to mathematical logic. His legacy lies in the systematic and rigorous approach he brought to the study of mathematical reasoning, as well as the specific results he attained. His enduring influence on subsequent generations of mathematicians is a testament to the lasting value of his work. Benjamin Peirce's thorough investigation of mathematical logic exemplifies intellectual rigor and precision. His contributions, while influenced by the intellectual climate of his era, remain foundational to modern mathematical logic. His dedication to clarity and precision in defining logical terms and developing symbolic languages continues to influence contemporary mathematical methods. His lasting impact extends beyond the specific results he achieved, profoundly shaping mathematical thought itself.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.